Well, welcome back. You have now had a day to practice with your geometry and all those rectangles, remembering and feeling the pain of the Greeks as they did not have calculus at their disposal to be able to solve these and were forced to just rely on geometry. We are going to spend pretty much the rest of this week doing geometric methods before we move into the calculus-based methods, but we're all just laying the groundwork for what we're going to learn. So today will be another geometric method as well as the calculator program. All right, let's see here. Okay, just a reminder about the accuracy of using the rectangular approximation method. So we saw yesterday that when you have an increasing function, when f prime of x is greater than 0, that the LRAM will always underestimate, whereas the RRAM will always overestimate the two. So LRAM under, RRAM over. But then vice versa, when you have a decreasing function, so when f of x is less than 0, then the LRAM is an overestimate with too much area, and the RRAM is an underestimate with too little area. And if you have a combination of both, if your graph is partially increasing and partially decreasing, you go with what the majority is. So if there's a greater number of rectangles, under the increasing function, then you'll go with that. If it's completely equal, then that's actually good, because then the under and the overestimate will cancel each other out. So we talked about how getting more accuracy would be, one way would be to add more rectangles. But another way to get more accuracy is to shift your rectangle to be more of a mid rectangle. So not the left corner being on the curve and not the right corner being on the curve, but having the rectangle, the curve go right through the center of that rectangle. And so that would be a partially underestimate but partially overestimate. Let's zoom in. Like if you can see here, you can see it's overestimating that area but underestimating that area, and those two areas cancel each other out and negate each other. So a better way is what's called an MRAM, a midpoint RAM. So we're going to talk about how to find that today as an improved method. So we're going to go back to the same example we were working on before, and we are going to do what's called the midpoint method. Now, this is more accurate, but you have to kind of go every other value in order to create a midpoint. So rather than having rectangles created on all the 0.5s, we can only have rectangles created, I said it backwards. Rather than having rectangles created at all the 1, 2s, and 3s, we have to be at the midpoints, which halfway between is 0.5. So if you're looking at from 0 to 1, the middle of that is 0.5, and that is where we're going to create our rectangle. And so the rectangle would come across, and this rectangle is going to be completely underneath, so that'll be an underestimate of that rectangle. The next rectangle would go from 1 to 2, so it would be created at the midpoint, which is at 1.5, and so that rectangle would be partially over and partially under, and so that's going to be a really good estimate right there. And the final rectangle would be between the interval of 2 and 3, so we go to 2.5. And again, that rectangle will be partially under and partially over. So we're going to have a really good approximation of the amount of area underneath this curve. So an MRAM would be the base, So the first base, let's do the red one. The base is 1, but the height is 2.75. That's the middle height of that. And then let's do the blue one. So plus, the base of that is 1, and the height of that is 3.75. Okay, remember here I'm finding the heights at 1.5 and the height at 0.5 and 1.5 and then 2.5. So the third one plus a base of 1 and the height of 6.75. And so I only have 3 rectangles, but I'm going to have a better estimate than either the LRAM or the RRAM was. So we come up with a total of 13.25 square units as our best approximation so far of what the area under this curve is going to be. So what MRAM is not, okay, this is a common misconception, but MRAM is not an average of LRAM and RRAM. That's a separate thing. We did that yesterday, and we did not get 13.25. So the reason is that the curve, okay, these curves are not equally distributed along the interval. So they're not symmetric. Within an interval. So let's just go back and look at that. Okay, if I pick any one of these, okay, let's focus on this one. This curve has a different slope to it than this section of the curve. Those are not perfectly symmetrical. One is steeper than the other. The function is getting steeper as it goes. Therefore, these two little, they're not triangles exactly, but they kind of look triangular. This little triangular shape is slightly smaller than this triangular shape. It is not perfectly symmetric. That's why it's not a perfect average between MRAM and RRAM. So please don't assume that these are perfect averages. They are not. The curve, because of the concavity of these curves, they are not perfectly symmetrical, so it's not a perfect average, but it is a better estimate. Okay, so MRAM is not an average. What MRAM is a better estimate than any of the ones we've done so far. It's better estimate than either LRAM or RRAM or even the average of the two. All right, it works on velocity as well. So if we're going to use the MRAM principles applying to velocity, we have to make our region bigger. So we don't, like if we were doing RRAM, we would do the interval from 0 to 7. But if we're doing MRAM, we need a larger interval, so we're going to need to go all the way from 0 to 12, and we're going to use the value of 36. So the MRAM would have a base value from 0 to 12, but a height value of 36. Okay, and then the next one would go from 12 to 26 using the 48. So the next one would be a base value from 12 to 26. That's a base value of 14 and 48. And then the last one would have a base value from 26 to 35, so that's only 9, and then a height value of 40. And then we add those, multiply and add those up. Then we come up with 1464, and the units when we were in feet per second is now going to be feet. So our best estimate so far of this car traveling down the road is 1464 feet. So how can we improve the accuracy of this method? More data, first of all, which would allow us to do more rectangles. The more data you have, the more rectangles you have. The more rectangles you have, the greater the accuracy. But that's going to take forever. Okay, we'd love to be able to have lots and lots of data and do 100 rectangles, or then we're going to really have some accurate values, but we don't have an infinite amount of time. So now we're going to use programming to save time, and that's where the RAM program comes into play. So we really have an advantage over the Greeks. All right, so hopefully by now you've either loaded from me or created the RAM program. And we're going to launch these RAM programs to allow us to find 50 rectangles, 100 rectangles, so many rectangles to help us get an even better and more accurate. I mean, if we could, we would be doing a rectangle along every single little interval here in between. Okay, if we could you imagine how long that would take us to do rectangles of 0.1 instead of 0.5? All right, we're going to do our best here to record this and see how it goes. All right, so first of all, you want to make sure that you have the curve put into your calculator into Y1. So we'll do that first. Once you have the curve put in, you're going to launch the RAM program. So you want to go to the program key. All right, so we're under draw, it says program. And then these are the ones I've loaded onto your calculator. And we want to pick number 3. So we'll pick RAM number 3. And you just hit enter to launch it. And it's going to ask you a couple questions. Your A value, so where do you want to start? So we would like to start at 0. And then hit enter. And the B value, well, we want to stop at 3. So we'll hit enter again. And the number of intervals, that's how many rectangles we want to do. Well, I'd like to start with 50 as the number of intervals. So I'm going to put in 50 and I'm going to hit enter. And I'm going to watch the calculator spin its wheels. And boom, it gives me a left value and a mid value and a right value based on 50 rectangles. So 3.3218, 13.4991 for mid, and 13.6818. And so we know the left is going to be an underestimate because this is an increasing function. The right will be an overestimate for the same reason because it's an increasing function. And the mid will probably be pretty darn close to what the actual one is. So let's run the program again. Let's do 100 rectangles. So I'm going to hit program one more time. Go down to option number 3. Whoops, too far. And this time, I would like to still go from 0 to 3. And this time I'll ask it to do 100 for me. So its wheels will spin. And now we have a tighter amount of accuracy, 13.41, 13.499, and 13.59, etc. Okay, so again, tightening up on what the accuracy is of this. And of course, if we did 500 rectangles or 1,000 rectangles, it'll take the calculator longer, so it'll spin for a little bit while it's figuring that out, but it will definitely increase our accuracy. Okay. So we can also run a RAM program to find under trig or logarithms or exponentials or any other kinds of graphs. And so we can run the RAM program here to find a bunch of rectangles all bounded underneath this trigonometric graph. So you would run the same thing, okay, specifying how many rectangles you want. Now the questions, the homework questions will give you, a specification of how many they want you to do. So if it'll usually say in a little subscript here, maybe 25 or something like that. So it'll give you a subscript of how many rectangles it wants you to run, and will always give you the interval running from 0 to 3. So why don't you take a minute, pause the recording, okay, type in, make sure you're in radian mode first of all, type this into your Y1, run the RAM program, and let's just all try 50 together, and then we'll try 50, and then why don't you resume the recording and just double check to make sure you know how to run the RAM program correctly. All right, so congratulations. Hopefully you ran your program, and if you did it correctly, then your LRAM value would have been 5.736. Your MRAM value should be 5.778, and your RRAM value for 50 should be 5.812. So let's talk about the accuracy of this. We've got most of the function is an increasing function. So f prime of x is greater than 0 for a majority of the function, and for about a third of the function, f prime of x is less than 0. It's a decreasing function. So we're going to say for the majority, for the increasing, okay, that the left would be an under and the right would be an over. But for the decreasing part, it would be the opposite. But because a majority of this function is increasing, we'll say that the left is an under and the RRAM is an over. But the MRAM is going to be our best bet, our best option for this. Okay, if you have to justify why the RRAM is an overestimate or why the LRAM is an underestimate. All right, so that's all the rectangle work we're going to do. We'll come back on Thursday and we'll tackle another way to improve the accuracy of areas under a curve. All right, so I will see some of you in person on Thursday. I'll look forward to that. All right, have a good afternoon. Bye.